Okay, so the next thing we want to talk about is actually how to interpret one of these guys, one of these crosstabs. And um, I just want to pull this down for a second. The things that we're going to talk about in terms of interpretation are these four lines of interpretation. That is your DV, the relationship between, identify your dependent variable and your independent variable, their strength and direction. You want to also talk about the amount of variance, explain, and statistical significance. You finally want to interpret the chi-square, and then finally the overall interpretation of the relationship. Okay, so here the first thing we want to do is identify a dependent variable and an independent variable. And our dependent variable, as we discussed in the last video, is gang association. Our independent variable is sex. Alright, and we know that because again our 100% are in the columns, and therefore sex must be our independent variable. Alright. We also talked about last time that because it appears that SPSS is treating gamma as a measure of as the appropriate measure of association, probably because these categories are 0, 1, and 2. It's looking like it's showing direction, but it really isn't. But nonetheless, we're going to use the gamma as opposed to the lambda association here so that we're not confused. Alright. Alright, so in terms of your interpretation, the first thing you want to say is the dependent variable, gang association, and the independent variable, sex, show a moderate positive relationship. Okay, so where do I get that? This number here, the gamma value is 0.343. Alright, and remember last time I showed you or told you that as long as the value is around 0.35, that would be considered a moderate relationship. And so that's the value, that's gamma, and it's around a 0.35. Alright? Alright. The next thing is this relationship. Oh, and it's positive because there's no negative number in front of that value. Okay? This relationship is significant in the sample, and in parentheses you write gamma is significant in the sample at the 99.9% confidence level. Alright, and in parentheses write gamma is equal to 0.343, semicolon, p is equal to 0.000. Alright, so again I got those numbers. Alright, well the gamma value is obvious. Again, it's 0.343. The p value is here. Alright, and it is below. If you notice or look in your notes and note that it is below 0.05. It's also below 0.01, and it's also below a 0.001. And remember, if it's equal to or below, it's considered significant at that level. In this case, it's significant at the highest level of significance, and that is 99.9%. Alright? Because it is 99.9% gives you a p-value equal to 0.001, and this p-value is equal to 0.000. And again, I got that number from this right here. Okay? Alright, in terms of chi-square, this chi-square is the value above here. Alright, that's our chi-square value. It's 25.700. Degrees of freedom is equal to 2, and the p-value is equal to 0.000. Okay, the chi-square, or this relationship, can be inferred to the population as chi-square is significant. Okay, and in parentheses, chi-square is equal to 25.700. Degrees of freedom is equal to 2. P is equal to 0.000. Alright? Alright. And again, the chi-squares are inferential statistic. As long as it's significant, it doesn't matter how significant it is. As long as it's significant, we can infer the relationship to the population. But also note that the sample statistic, which is the gamma or the lambda, must first be significant before you can infer that relationship to the population. Alright? So again, as a review, gamma and lambda are our sample statistic. The chi-square is our inferential statistic. And the sample statistic first must be significant before we can infer it to the population. Alright? And finally, overall, and you go back to your contingency table to make these assumptions, it's saying that it is a positive relationship. So let me give you a little tutorial on that. Alright, when it's positive, a positive relationship is saying that the higher values or the lower values, but let's go with the higher values, that the higher values on one variable are associated with the higher values on another variable, on the other variable. Okay, so what does that mean? This 0, 1, 2 are our values over here, and 2 is the highest value on this end over here. Alright, 0, 1 are our values on this end. 1 is the highest value associated on that independent variable. So basically it's saying that this 2 is associated with this 1, or you should interpret the relationship as males are more often thought about it and joined a gang. Alright, and that's what you would say overall. Alright, males thought about it most often and joined the gang. Alright, and so that's what we put down here. Overall, the relationship indicate that males most often thought about it and joined a gang. Okay? Now, if the relationship was negative, and I need to just talk about this, a negative relationship associates the higher values on one variable with the lower values on the other variable. Okay, So if this was a negative relationship, and we know that it's positive because the gamma value is positive, but if this was a negative relationship, we would then say we would associate the 2, which is a higher value on the dependent variable, with the 0 on this side, which is the lower value on the independent variable. Okay, and then in that case, our interpretation would be that females most often thought about it and joined. All right, that would be a negative because it would be high here, low here. All right, all right, and so that's what a negative association tells you in terms of how to interpret the values. High on one, low on the other. Positive says you go high on one and high on the other. You can also go low on one and low on the other with a positive value, as long as the association is in the same direction. Low, low, high, high, or for positive, and then for negative, low, high, or high, low. Okay? Alright, so let's look at this interpretation. Again, our gamma, we're focusing on our gamma. It is positive. This is our chi-square up here. This is our contingency table up here. Because we know it's a positive, we're going to go again in terms of our overall interpretation with the high interpretation. So high value on one variable is associated with the high value on the other variable. Okay, and we know from our univariate analysis that 0 was out of county and 1 was in the county. Alright, so with all that said, let's interpret. Alright, the dependent variable is gang association, and the independent variable is county location. Alright, this relationship shows a positive weak association. Okay, again, we're looking at our gamma value for that is 0.169, so it's below a 0.20, which I told you would then indicate a weak relationship. We know that it's positive because the value is actually a positive value. Alright, this relationship is significant in the sample at the 95% confidence level. Gamma is equal to 0.169 and P is equal to 0.022. Alright? Alright, it's 95% because 0.022 is below 0.05, but it's not below 0.01, which would make it 99%. Alright? This relationship can be inferred to the population as chi-square is significant. Alright, and chi-square is equal to 11.288. Degrees of freedom is 2. P is equal to 0.044. 11.288. Degrees of freedom is equal to 2, and the P is equal to 0.004. Alright. Overall, this relationship indicates that most often those respondents who resided in the county most often thought about and joined the game. Okay. Right, and I got that up here. Positive relationship, high value on the dependent variable is associated with a high value on here, and one is in county and thought about it and joined the game. Okay.